Hello everyone. In this video, we are going to cover the topics which are the types and properties of quadrilateral, which means quadrilateral is already known to us what it is, but now we will do some types and associated properties with them. So first of all, we have to study about the parallelogram. Okay, and parallelogram is already clear to us. Let me make again. Okay, suppose this one is parallelogram in which opposite sides are equal, which means A, B, C, and D. AB is equal to CD and opposite sides are parallel also. Similar way, AD is equal to BC and they are parallel. So, in this, the very first property is that a diagonal of parallelogram divides it into two congruent triangles, which means, suppose if we make diagonals there, the first one is BD and second one is AC. So diagonal of parallelogram, if we consider now only one, which is BD. So this property says that triangle ABD is congruent to triangle CDB. Okay, and if we make this diagonal AC, then one property also hold, which is triangle ACD will be congruent to triangle CAB. Okay, now I am going to prove this for the first one ABD and CDB. For the next one, you can try by yourself. Okay, now look into the triangle ADB. Okay, in triangle ADB and the triangle CBD. Okay, so what we have according to the properties of parallelogram, the AD is equal to BC. Okay, we have side AD is equal to side BC. Why? Because opposite sides of parallelogram are equal. Okay, in this similar way, we can say CD is equal to AB. Okay, this one are the CD and AB because opposite sides of parallelogram are equal. Now, if you look carefully in these two triangles, the diagonal BD is common. So we can directly write without any condition that BD is equal to DB. Okay. Now observe this side is equal to this side. Okay. So, and this side is equal to this side and diagonal is common. So can I write triangle ADB is congruent to triangle CBD by criteria of side, side, side. Okay, you can check this one by yourself. So it's proved for us that a diagonal of a parallelogram divides it into two congruent triangles. Okay, so that's one for the diagonal BD. You can try and it will be like in the same way. Okay, for this one. So I hope this property is clear to you. Now the next one is that each pair of opposite side of a quadrilateral is equal, then it's a parallelogram. Okay, which means suppose we have any quadrilateral like that, in which it's given that each pair of opposite sides are equal, which means this one is equal to this one. Okay, A, B, C, D. So in A, B, C, D, we have only given that AB is equal to CD and this one, AD is equal to BC and AD is equal to BC. Then we can directly write, or it implies that ABCD is parallelogram. Okay, it's the only sufficient condition for this one. Okay, so that's for this property. Now the next one. In the parallelogram, opposite angles are equal. Okay, in this one. So we can prove this one also. Let us make the diagonal. Okay, and using the property 1, can I write triangle ABD is congruent to triangle CDB? Okay, this triangle is congruent to this triangle. Okay, we can use the property 1, which we have did. A diagonal of a parallelogram divides it into two congruent triangle. So using this property, I have written this thing. So when two triangles are congruent, then by CPCT, we can say their corresponding angles are also equal. So angle A is equal to angle C. So what it is? One pair of opposite angles are equal, or in same way, we can do angle B is equal to angle D. Okay, if we make diagonal AC. Okay, so this property is very simple to prove and we can follow this one by using the property number 1. So that's it for this property. Now the next one, it's written there that in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram, which means suppose we have given a quadrilateral. Okay, this one is the quadrilateral given to us, and it's given that this angle is equal to this one. Suppose their vertices are A, B, C, and D, and we have angle A is equal to angle C, and these two angles are also equal. Angle B is equal to angle D. So without any proof and using these two, we can directly say A, B, C, D is a parallelogram. Okay, that's for this property. Now the second one, or we can say it's the last one. No, second last. Okay, so it's written there that the diagonals of a parallelogram bisect each other. Okay, and we can prove this one also, which means let me make diagonals. So they will be like this one is BD and this one is AC. So we have to prove that diagonals bisect each other, which means these two are equal. Okay, and suppose this point is O, then we have to prove AO is equal to OC and OB is equal to OD. Okay, and at the starting of this chapter, I already told to you that to study this chapter, you should be very clear about the triangle and the properties of congruency. So the same thing we are going to use to prove this thing. Okay. Okay, now look there. We are considering the triangle AOD and the triangle COB. Okay, if we consider these two triangles, then how we can prove? That's the question. So we should use some properties which we have already did. Okay, now look there. In these two triangles, can I write angle AOD is equal to angle COB as they are vertically opposite angles. Okay, so that's the thing. And I can also write AD is equal to BC as opposite sides of parallelogram are equal. Okay, so what we have done till now, this side is equal to this side and these angles are equal. Now we know that in a parallelogram opposite sides are parallel, so AB is parallel to CD. Okay, and angle DAC and the angle ACB. Okay, these angles. Angle DAC is this one and angle ACB is this one. They are opposite interior angles, or we can say if AB and CD are parallel lines and AC is the transversal, this one. So this angle should be equal. Okay, these two are parallel and these two are also parallel. So if I draw like that, then this angle should be equal. So we can write angle DAC is equal to angle ACB. Now what we have, these sides are equal, these angles are equal, and this is also equal. So using the criteria of angle side, triangle AOD is congruent to triangle COB using angle side criteria. Okay, so now we can say that as these triangles are congruent, so by CPCT, their corresponding sides are also equal. So AO is equal to OC and OD is equal to OB. Okay, that's the thing there. So it's proved for this property. Now the last property for the parallelogram is that if the diagonals of quadrilateral bisect each other, then it's a parallelogram. The just converse of the previous one. Suppose this one is the quadrilateral and it's given that its diagonal bisect each other like this, which means if it's A, B, C and D and the point of intersection is O, it's given that AO is equal to OC and DO is equal to OB. Then we can directly say ABCD is parallelogram. Okay, in this chapter, the most important quadrilateral which we have to study and the given in the NCERT textbook is parallelogram. Okay, so we have done many proofs and some properties. Now for trapezium and rhombus square, I also have some properties there. So first of all, for trapezium, as we already know, okay, so a quadrilateral with one pair of parallel lines, which means this one is parallel to this one, Only one pair of opposite sides are parallel, which means this cannot be parallel. Okay, only one pair we should have to follow this thing. Non-parallel sides are called legs. Okay, and which means these two sides are legs. These are the legs, and it's their misprint. We have to write C, which means we can say AB and CD are legs. If legs are equal, then isosceles trapezium. Like if AB is equal to CD, then we can say the trapezium is isosceles. Okay, and in that case, base angles are also equal, which means that angles only in the case of isosceles trapezium, and diagonals are also equal. Okay, and for parallelogram, we have done so many properties, and that's are written there. Now for rhombus. Okay, it's a parallelogram with all sides are equal. Okay, so for a rhombus, we can draw like that. Okay, that's the rhombus. But in the given figure, you will see that there is some associated triangle, and we can draw like that. Okay, so it's used to prove some properties. Okay, and if we draw there, then these two are congruent, this triangle and this one. So that's why it's drawn there. So a parallelogram with all sides are equal, which means this one, this one, this one, this one are equal. All sides are equal, then opposite sides are parallel, this one are parallel. Diagonal bisect each other at 90 degree. Okay, this one is new. Suppose these are the diagonal, then they bisect each other at 90 degree, which means this angle are 90 degree and this are equal, which means if this is O, then AO is equal to OE and BO is equal to OC. And diagonal bisect opposite angles also, which means this. Now for square. So square is parallelogram with all side equal. We have done this thing. All sides are equal. All angles is equal to 90 degree. Okay, and opposite sides are also parallel. This one. And diagonals are equal and bisect each other at 90 degree. Okay, that's the difference between square and rhombus. All properties are same except in rhombus, diagonals are not equal. But in square, our diagonals are also equal. Okay, and square is both rectangle and rhombus because it satisfies all the properties of rectangle and rhombus. So it's all for this video in which we have done some types of quadrilaterals and their properties. So keep practicing and do study. If you got any doubt, then feel free to ask through my Urban Pro profile.